Hi, this is Eric Roney from the Walker School of Business and Technology at Webster University, coming at you again with another Excel function. In today's tutorial, I'll be showing you how to use the SUMXMY2 Excel function. Let's get started. The SUMXMY2 function is a really useful function, and really what this function does is it takes two arrays and it takes the difference of those and squares them and then sums that square difference. So if you wanted to look at this as a definition, you use this when you want to calculate the sum of differences squared. So this is the differences, all right, squared, and we're summing that. So sum of these differences squared. And this is done in a corresponding array. And what this measures is distance between two sets of data. All right, so here we have an array and we see we have various target markets that are measured on these different variables. And so what we can do is we can measure the distance between target market 1 and target market 2, or target market 1 and target market 3, target market 2 and target market 3, etc. So we can use this then to see how closely maybe two target markets are to each other or how far apart they are from each other, and maybe we want to combine two target markets, or maybe we can combine efforts and create some efficiency if we know that two target markets are similar to each other. We could also do this, instead of doing this vertically, we could do this horizontally if we wanted to. And we could measure variable 1 of satisfaction and variable 2 of satisfaction and see how closely together these are to each other in relationship to the different corresponding rates from the various target markets. And then we can measure satisfaction 1 and satisfaction 3. And we could see if maybe we can combine these into two, satisfaction variables, combine them into one offering of some sort. So maybe if these were different elements, different product elements, you might be able to do something where you could combine these and say, oh, these two are closely related together, and so maybe when we have a package deal, we want to package these together because they seem to have high correspondence together of some sort. So that's a way to think about this sum x minus y2 function. All right. One of the things that you should think about is this square. What is the purpose of this square? And really a good way to think about this is to compare this formula to that of the variance formula. And they look very similar, and really the difference is with the variance, we're looking at only one set of data. All right, so this is your formula, x minus the mean of whatever this x data is, squared is your variance. So this is used to calculate the amount of variance, or the amount of how much data is different from the mean. And if you remember, the mean is the middle point of the data. All right, so we have all of these different variables, all of these different numbers that we have, and the mean represents that middle point, but all of those different x values are numbers that are not the mean. They're different from the mean. So this variance is a measure of how much variation there is in the data from the mean. Okay, the sum x my2 is a measure of two sets of data and how apart they are from each other. So to really remind you of this variance, so all I've done is I've taken target market 1, that information, and I've copied it over here and I've calculated the mean, which is 3.43. So 3.43 is the middle point, the average of this data, or the where this data kind of revolves around. All right. So if we wanted to see and get a measure of the variance of this data, and we simply try to calculate the difference by taking this minus the mean, taking this minus the mean, you see what we get. We have 4 minus 3.43, and we have 0.57, and etc. So some variables are below this mean, some variables are above this mean. So we have positive and negative numbers. Well, when you add these up, when you sum these to get an overall measure of the variance, it turns out to be 0. And the reason this turns out to be 0 is that we have what's called normal distribution. This is all normally distributed about the mean. And so we have just as many numbers above the mean, or just as much variation above the mean as we do below the mean. So when you take those differences, they cancel each other out. All right. So in order for us to measure this distance, we have to get rid of these negatives so that we can see, I mean, the distance from this 2 to this 3.43 is negative 1.43, but the distance really is just 1.43. It's just in a negative direction. So if we were to get rid of this negative, then we can actually calculate this in a way where this 1.43 doesn't cancel out part of this 1.57. All right, we want this to be added to it, not cancel it out. So in order to do that, we could do the absolute value here, or we can take the squared of this. By taking the squared of this, what we do is not only get rid of the negative, we also create an exponential amount of magnification for anything that's farther away from the mean. So if you think about this, 1, 2, 3, 4, 5, if we take the squared of each one of these, and I'm just going to calculate that here real quick. All right, the square of 1 is 1. The square of 2 is 4. The square of 3 is 9. You can see the further we get, the higher this number gets, the more the magnification happens as we square it. So by the time we get to 5, we're now magnifying that to 25. All right, so that's basically what we're doing here. The further you get from the mean, the more it's magnified. And that's what this variance is calculating. So if I were to do the same thing here, I'm just going to copy this over since I have that here. So this is just the squared of this 0.57. I'm going to copy this down, and then I'm just going to copy this over. And you can see that our total variance as a measure is 13.7. All right. So that is the variance, and then to get the standard deviation, all we have to do is take the square root of this. That gets rid of the squared term, and we get back to the original units that we were in. But anyway, I wanted to state that because that helps to really kind of explain why this squared is necessary. When we're comparing numbers that are positive and negative to each other, well, we don't want those numbers to cancel each other out. So we can do square to alleviate that. Or I'm sorry, not when these numbers aren't negative to each other, but when we have numbers in here that are negative and some that are positive, we need to take the square of that. And we also want to magnify whenever x is significantly different from y. So the greater this distance, x from y, the more it's magnified by that square. All right, and the same thing with variance. So variance, again, is a calculation for one variable and the variation within that variable. But if we wanted to see the difference between target 1 and target 2 as a measure, and how different are they, well, we could do something that's called a t-test. And the t-test compares our means from each other and gives us a significance of the distance between these two. So remember, this mean is the middle point of this data. This mean is the middle point of this data. And so it gives us a good measure of, the average we could expect in terms of the difference between these two. And the t-test is good for some things. If we just want to see if these are significantly different from each other, we could use a t-test. But in the case of the sum of the differences, what we want to do is not simply look at an average difference between the two and see if they are significantly different from each other. We want to measure how much difference there is between each other. And so we want to take the difference of each one of these from each other, square it, and then get an overall measure. All right, so that's what we would do here. So I'm just going to show you an example here of how that's done. SUMXMY2 is what we're doing. Uh-oh, didn't mean to do that. Let's try that again. Not an at sign, a to sign. Okay, and let's take this in parts. Let's do it this way. Let's take this in parts. Sorry, let's take this in parts. So let's do let's just do the differences of x and y. Okay, and then we'll do a sum of that, and I'm just going to cut that and move that over here. Okay, so if we take the difference between this and this, we get 2, which we expect. I mean, you can calculate that in your head. And so I'm just going to copy this down. All right. And so you see where there are some that are exactly the same, some that are different from each other. And we could sum that up. But again, we want to magnify the difference between these two. And you can see there's no negatives here. So it looks like all of these are larger than all of these, but there could be some cases where some of these are smaller than some of these, resulting in a negative here, and the possibility of these canceling each other out would be there, although that is not the case here. All right, so for instance, if this number instead of being 2 were a 5, then this becomes a -3, right? And so this -3 would cancel out that 3, and we need to get rid of that -3. All right. So now we are going to take this x minus y, and we're going to square this x minus y. And let's just make that so that you know this is squaring what we're doing here. All right, so all I'm going to do is equals this, and this, to do the square, you do that little caret symbol that is above the 6 on most keyboards, Shift 6, and I'm going to put a 2 in there. And so we know the square of 2 is 4, and I'm just going to copy this down, and you see the square of 0 is 0, so there's no magnification there because there is no number, but 3 now is magnified even greater to 9. And so to sum this, all I'm going to do is come down here and take the sum of this. And so This would then be the sum of x minus y squared, 26. All right, so that's the long route of doing the sum of x minus y squared for these two. However, instead of us doing it this long way and then having to do this for target 1 and target 3 and then target 1 and target 4 and target 2 and target 3, etc., we can have Excel do this using a formula. All right, so I'm going to come over here to this data right here. And if you remember, I said we could either do this by comparing target markets to each other, or we could do it horizontally comparing these to each other. So first, I'm going to do the target markets compared to each other. So what I'm going to do is just copy. Let's just do this real quick. Copy this down here. I'm just creating another table, but I'm getting rid of this because I don't need this information. And this right here, I'm copying over here because what we're going to do is we're going to compare these to each other. All right, and I'm just going to flip this that way. Let's try this again. Flip it that way. And let's just do a paintbrush here so that let's get rid of these because those are not necessary. Let's try that again. For some reason, this all did not work. Try that one more time. There we go. All right. So basically what we're doing here is that we are comparing target market 1 to target market 2, target market 2 to target market 3, etc. All right. And we know in this diagonal, when we compare target market 1 to target market 1, it's going to be 0. So here, this would be our comparison of target market 1 and target market 2. Okay. So we can do this, and the way we would do this is to simply use our sum x minus y squared calculation. But before I do that, what I want to do first is I'm going to name each one of these data sets so that it makes it easier for me to just type in. So to name a data set, all you have to do is highlight what you want to name. I'm not including the title of this data in this, just this part right here, the data itself. Then I'm coming up here to the window, which is the location for this cell, and right now it says E3 because that's the beginning cell of this data. And I'm going to put my cursor in there, and I'm just going to type in TM1, all right, and hit enter. Oh, so that did not work, and the reason that didn't work is because TM1 is an actual cell in our workbook. On this worksheet, TM1 is an actual place. So when I typed in TM1, it actually went to TM1. So that's not going to work. We're going to have to try something else. So let's say target, let's see, TGM1. All right. And let's say TGM, just in case there's a TGM column. I don't think there is, but just in case there is, TGMK1. Target market 1. All right, and hit enter. Oh, that didn't work right. You know why? Because I didn't highlight all of this. All right, so if you make this mistake where I didn't highlight all this, and now let's say I want to highlight all this and use this TGMK1, and I hit enter, guess what? I've already assigned just this cell as TGMK1. So if you make that type of mistake, go over to formulas, and you could do name manager here, and you could see here where it's TGMK1, and it says what the value is because that the value is 4, and it tells you what it's referencing. It's referencing only this E3. Well, that's not what I wanted to reference. I wanted to reference all of this. So I can go in here and actually change this, and I'm going to drag this on down so that it's the whole set of data for target market 1. So that's E3 through E9. All right, and hit enter, and then I can close this out. Yes, I want to save that. And so now if I type in TGMK1, you see it highlights all of that. So every time I reference TGMK1, it's this data array. Now, as you can always go to Name Manager and find out what's what, but it also may be good for you to just make a note somewhere of what stuff is. And you could do that for all of them. I'm just typing it here to show you a demonstrate, what it would look like. But you might want to do this on a separate sheet, just for a reference guide. All right, so I'm going to do this for the next one, TGMK2, hit enter. Do it for this one, TGMK3. And even if I did this as a lowercase m, it wouldn't matter. I believe it's still going to take you to the same place, whether or not you use a lowercase or an uppercase. All right, so now I have my reference names that I'm going to use down here. So I'm not worried about this cell right here, because this is a comparison of target market 1 to target market 1. And the distance between these two is 0 because it's the same data. There is no difference between the two. All right, so we don't have to worry about that one. But this one, I do want to see and measure the distance. So I'm going to say equals sum X, and as soon as you start typing that in, you get this reference guide that you could use. And we have several different ones, and I'll talk a little bit about this sum of squared differences versus the sum of differences squared. All right, and we're using the sum of differences squared instead of the sum of squared differences, which is this one. So be careful that you don't use sum x2 my2, because that's different. All right, so sum x my2 is what we're going to use, and I just double clicked on that, and it says, okay, what's your first array? Now I can come up here and I can actually highlight what I want here, and you see as soon as I do that, it says, oh, you want TGMK1. That's exactly what I want. So I could either highlight it or I could type in what I want, since I have already named this reference. Comma, so it says, okay, what's your second array or your Y array? And my Y array, I'm just going to type it in now, MK, and you see it brings up a list, and I can just double click on that. And you can see that it highlights this second one, and yes, that's what I want to compare. So I close off my parentheses, and if you remember, we got 26 before, and guess what? We got 26 again. So over here, when I calculated this, the long route, we got 26, and now here, we got 26 again. All right, now I can copy this over, and right now it's going to be 26 because it doesn't know to move this over. But I could simply change this to a 3, and voila, we have, and you can see now that when I put my cursor up here, you can see what it's referencing, these two. And here, if I put my cursor in here, instead of copying or typing over this and changing that to a 4, I could just take my mouse. Let's see if this will work. Well, it's not letting me do it. So we're going to actually have to type this in here, 4. And you can see it jumped over to 4. All right. So we see that there is a distance of almost, well, not almost, twice as much. Target market 1 and 2 are twice the distance from each other as target market 3 and 1 and target market 4 and 1. So target market 1 and 3 are the same distance from each other as target market 1 and target market 4. They have the distance of 12. All right, so let's just copy this down and we can easily just change this. Well, see here, this is going to be 0. If I put a 2 in here, it's going to be 0, which is fine. And here I'm going to change this to 2. And this makes it so much quicker for you to go through and do this. All right, I'm just going to put in a 0 here. All right. And I'm going to copy this down even further. And here, this is going to be 3 and 2. This is going to be 3 as well, which is going to be 0 on that diagonal, 3 here. So again, this is looking at 3 and 4, 3 and 4 up here. All right. And if I want to copy and do it here, we could do it this way as well. And this is going to be 2. And this should be 1 actually. And this will be 3 and 1. And this will be 4 and 1. So you can see how quickly you can get through this versus if you had to do this by hand. It wouldn't work very well with it. So here, this is 4 and 2. And this is 4 and 3. And this one is 4 and 4, which will be 0 again on that diagonal. So one of the things you'll see is that this diagonal provides a mirror. All right, everything on this side of the diagonal reflects everything on this side of the diagonal. And that's one of the ways you'll know you did this right, because this cell right here is comparing target market 1 and target market 2. And so it's this cell, target market 2 and target market 1. It's just reversing this. Target market 1 and target market 3 versus target market 3 and target market 1. So you have a 12, you have a 12, 12, 12, 28, 28. 28, 28, 12, 12. So you can see here how it is calculated. And so now we can see how different or similar, and the lower these numbers are, that means that those markets are very similar to each other. And, you know, this is all relative. In and of itself, 28 may not have much meaning, 12 may not have much meaning. It's all in relationship to each other. And you know, we could see, let's say I came up here and changed this to in target market 2, so that is really similar. Not exactly, but really similar to target market 1. So you see how I've changed these, and you see that now this number is lower. It's 2. All right. And the distance then between these target markets is really similar. So we may compare these and see what we can do in terms of creating some efficiencies. You know, compare what are they satisfied on? What are some deals we might do, or some promotions we might do for these two, or maybe even combine these two, you know, in terms of target markets. So you could do this with things like comparing competitors to each other. How similar is our brand to our competitors' brands? So maybe here you have the competitor, you have your brands, and you have different measures of your brand, maybe perceptions on different things that the target market finds valuable. You have those listed here, and you find out how your brand measures on those, find out how competitors' brands measure on those, and see which brands are similar to each other and which brands are further apart from each other. So this can give you some really great information. All right, and that's how you calculate SUMXMY2. All right, now wanted to talk a little bit about the difference of SUMXMY2 and sum x2 my2. So this is the sum of differences squared. This is the sum of squared differences. So in this case, we're first squaring each variable separately, all right, and then we're taking the sum of that. All right, so there you have it. That's how you would calculate the sum of x minus y squared in your array. And again, we could do this, instead of doing target markets, we could do satisfaction. And we would just set up a similar array, except, I said satisfaction, except we would do it on the horizontal variables instead of the vertical variables. So here, what I would do is simply just copy these across and then do something like this where we do a paintbrush this way. All right. And we would have to eliminate this. And one of the first things I might do here is I might name each one of these, create a name reference for each one of these. But let me just show you how we would do this if we were to do it horizontally. Sum x my2 equals, and I want to do satisfaction, comma, compared to satisfaction 2. All right, and I probably would, let's put that in there, right? All right, and I probably would lock this in place by using my dollar, and I think that's what I'm going to do here. Lock that in place, lock this in place. So I'm just locking these in place. All right, especially since I didn't do a name reference. If you did a name reference, it automatically locks them in place. So we can see that the difference between satisfaction 1 and satisfaction 2 gives us an overall sum of difference squared of 3, measure of 3. All right, and if I were to copy this, of course it's 3 here, but I could go up here and now this is satisfaction 1 and satisfaction 2, but we want satisfaction 1 and satisfaction 3, so I could drag this down to 3 and hit enter, and then I could come here and put my cursor up here and then just drag this down to 4, etc. And this is another way that you could do this fairly quickly and get through this. And just drag this down here to engagement 2, and then here, and drag this down to engagement 3. And now you can see how different these are from each other. And if I were to copy this here, of course, I would drag this up here, and this would be 0. All right, and then I could copy this down and do the same thing for all of it. And then I could see how different each one of these variables are from each other. All right, so there you have it. Once again, that is the sum x minus y squared, or sum x y squared, sum x m y squared. Again, my name is Eric Riney from Webster University. You can contact me at my email information. You can also contact me on Twitter or LinkedIn, and certainly you can find me on YouTube. Join me for another one of my marketing analytics videos. There are more to come, and if you like this one, hit the like button, and you can also join my page. Take care, and I'll see you soon.